So, thank you very much for the invitation. And what I would like to present today is a kind of in progress work that I would like to consider for the contribution, but um, I would like to have some of your insights to perfect it. So the topic today will be the what the term mathematics stand for in medieval and 13th century philosophy of mathematics. And the first things I would say to introduce the topic is that for scholastic philosophers, especially from the 13th century onwards, mathematics is often conceived as a mixed bag, but when it comes to its nature and objects, there is general consensus on mathematics being an abstract science about objects separated or separable from matter in thought, but not in existence, that is abstract quantity. This amounts to viewing mathematics as a unified science with a unified object and method, which would be abstraction. I mean, from this very description. However, problems for such a view emerge when one looks at the institutional and epistemic divisions of mathematics into the four disciplines of the quadrivium, which was common to 13th century philosophy, corresponding to that of quantity into its four species. On the basis of those divisions, some scholastic thinkers face the problem of the unity of mathematics resulting from the equivocality, if not the incommunicability, of at least two of those species in virtue of their principles, the continuous and the discrete quantity, whose respective principles were the point and the unit. These principles give rise to two different objects, each being the subject of its own proper attributes. So, as the unity of a science is supposed to depend on that of this object, of which the science in question is expected to demonstrate the proper attributes, how could they think of the unity of mathematics if the continuous and the discrete quantity can't univocally be one quantity? In other words, if quantity has had no theoretical unity, how could they speak of mathematics as a unitary science about quantity? In their own terms, the question was that of the universal material and formal cause of mathematics, the medieval instance, or what I see to be the instance of the Aristotelian discussions on common or universal mathematics, mathesis universalis. In this talk, I would like to suggest that those discussions deal with nothing but abstraction. Abstraction, or what some of the so-called didascalic tests or introductions to philosophy refer to as the universal formal cause of mathematics, stood in fact for the mode of cognition and of definition which was common to all the arts of the quadrivium, and that made them to be mathematical, the consideration sine materia, without matter, of what can but exist in matter, that is, quantity. So I will proceed in three stages. First, I outline the main points of the discussion as it occurs in one of the most, if not the most influential 13th century didascalic test or introduction to philosophy, which is the Accessus Philosophorum Septem Artium Liberalium. Secondly, I relate those discussions to some aspects of the Aristotelian theme of Mathesis Universalis, from Aristotle to Averroes, from which I deduce three models that could be useful for our analysis of the didascalic text. Thirdly, through a brief analysis of the discussion as we find it in the Accessus, I come to the suggestion that what medieval philosophers denoted by common mathematics was nothing but abstraction. I conclude with some remarks on the sources of such a view, as well as with a suggestion on how it could have shaped the scholastic view on the unity and the object of mathematics. So the first point, common universal mathematics in the first half of the 13th century philosophy, and the so-called didascalic text or introduction to philosophy, or simply Philosophia, were a set of medieval treatises whose aim was, among others, to prepare the students to the study of philosophy. The sum of those treatises covered the whole of the scientia, of the sciences, of which they proposed complex systems of classification. Some of them treated specifically of one science or set of sciences, either the discursive or the logical science, or the mathematical ones, And such was the case, for instance, of the Accessus Philosophorum, which I'll focus in, and of the Anonymous Questiones Mathematicae, and in another text, which you'll find underlined in the first page of the handout, the Compendium Circa Quadrivium. In the Accessus, after a series of definitions of philosophy and the author's division of philosophy, we find two common places for 13th century philosophy: that mathematics is about abstract objects on the one hand, and that the liberal arts of the quadrivium subdivide mathematics on the other hand. And this has for consequence on the side of the object a corresponding subdivision of the general or universal object of mathematics, which is said to be abstract quantity, into the specific objects of the arts of the quadrivium as its species, that is the four species of quantity. I quote the first text in the handout. First, it is asked, and all the translations are mine. The text is edited in Latin, so all the translations are mine. So first, it is asked, what is the subject of or material and final cause of the whole quadrivium? The subject of all mathematical disciplines is quantity, that is, things joined to motion and matter according to being, abstract in thought and in definition. As is said by Boëtius in the Arithmetica, quantity is divided according to a fourfold difference. One is continuous, one is discrete. Of continuous, one is mobile, one is immobile. Of discrete, one is absolute, one is related to something else. Arithmetic is about discrete quantity considered absolutely, music about discrete quantity related to something else. In the same way, geometry is about immobile continuous quantity, while astronomy is about mobile continuous quantity. And so we have the universal subject of the quadrivium and the specific subject of the special mathematical arts, on which we'll now speculate. So, from the point of view of the classification of sciences, such a description is unproblematic. However, the same is not true from the point of view of the object. Conceiving abstract quantity as a general and unified object under which the special objects of the arts of the quadrivium converge, as species, is far from being self-evident. If one takes abstract quantity to be the general or universal object of the whole of the quadrivium, and as far as the latter is what the term mathematics refers to, one might ask whether such a whole could or not stand for a kind of universal mathematics. To put it otherwise, what is at stake is the kind of unity both of the science and of the objects of the whole of the quadrivium. Such is the question raised and discussed by the author of the Accessus after the general presentation of mathematics. But in order to have a better understanding of the discussion, it would be convenient to outline its main aspects as it occurs in the history of philosophy from Aristotle to 12th and 13th century philosophy. So, when looking at the history of what Mathesis Universalis is, from Aristotle to especially to Averroes and Averroesian philosophy, the question of the unity of mathematical arts is not a novelty of the 13th century philosophy. We can track it back to Aristotle and his posterity, when it has been one of the main topics of discussions at issue in the commentaries. We find in Aristotle two occurrences of expressions associated with what has been called common or universal mathematics, Mathesis Universalis or Koine Mathematicae, etc., in two passages of his metaphysics in the book 6 and the book E and chapter 1 and K, chapter 7, respectively. And these texts are in the second text of the handout. But someone will raise the question whether first philosophy is universal or deals with some particular class, one kind of reality, for not even in the mathematical science is the method the same, because both geometry and astronomy deal with a particular kind of nature, whereas the first science is universally common to all. In the second text, however, one might raise the question whether the science of being as being is universal or not, for each of the mathematical science deals with some one determinate class of things, but a universal science, mathematical science, is common to all. So whatever this common or universal mathematics could be, it is clear from the context of those passages that Aristotle invokes it in order to interrogate the kind of universality proper to first philosophy. His aim is to see whether this latter is universal in its own way, or its commonness is like that of a mathematical science, which would be common to all the special mathematical arts and disciplines. He opts for the first option, that is a proper kind of universality. Without entering into the details of this discussion in its relation to other passages of the Aristotelian corpus, which discussion is, by the way, hard enough to resume here. And for that, I recommend in the reference the work of David Rabouin on the topic. One should note that Aristotle built his own view on common mathematics by opposition to kind of Platonic approaches, suggesting that common or universal mathematics was either a theory whose object would result from an analogy between magnitudes and numbers, and that posits that such a general object has real existence. I mean, I take objects which are incompatible from a general point of view, and I say that by this analogy, the resulting object is a real, is the general quantity, and it's a real one, and maybe the object of a universal science. And the other option, the other kind of Platonic approach is a theory that pretends to go beyond the proper domain of predication, one of the criterion for Aristotelian science, in view of giving a universal treatment of quantities via a general through the general theory of the even odd. I mean, as relations, treating quantities as kind of relations between the even and the odd. And all of them, what was common to this approach is that all of them make mathematical activity as a topic of second order. I mean, they are not directly concerned with mathematical activity, which is what Aristotle was searching for. And that's why he prefers a kind of mathematical theory, which is basically a theory of proportions like that of the book 5 of the Elements of Euclid. But I'll not discuss the details here. So from all this discussion, we should keep in mind that from the time of Aristotle, there was at least two approaches of common mathematics. A mathematical approach from within, concerned with mathematical activity in the search of the common genus of a common theory. And the second was a more philosophical and somehow meta-mathematical approach from without, I mean, from the exterior of mathematics, with a synoptic and analogical point of view of the whole of mathematics, somehow regardless of the mathematical activity in the search of the common genus. And to these two, a third can be added, which is an approach that we can label a nominal or total approach, according to which common mathematics is nothing but the name for the set of mathematical disciplines. And such was the approach of Alexander of Aphrodisias and Averroes, who both commented on Aristotle Metaphysics A1, not K7, and saw the commonness of common mathematics as depending on its covering various special disciplines. Now, with these three models, we can turn back to the discussion as it takes place in the Accessus. It should help us to identify what was actually at stake in those discussions on the universal formal cause of mathematics, which was, at the end of the day, a discussion on the unity of the mathematical disciplines. We would see that what was aimed by such a term was nothing other than abstraction or an abstract mode of cognition. So now the third moment of this talk begins, and I note that after the aforementioned descriptions of mathematics in the Accessus, where quantity is said to be the universal material cause, that is the universal object of mathematics, or of the whole of the quadrivium, the author raises a question on its universal formal cause that we find in text number 3. About the formal cause of the whole of the quadrivium, we ask whether it is one, and it seems that it is. For if there is one material universal cause as quantity, and if there is no matter separate from a form, then if there is a universal material cause, there must be a universal formal cause. The argument of the objection runs as follows, and which follows the text number 3. A first premise that says that there is no matter separated from the form. What I take as an underlying premise, any matter is proportional to one form or to its form. From the first and the second premises, there is a formal cause proportional to any material cause. Quadrivium has a unique and universal material cause, abstract quantity. Therefore, in virtue of the third premise, quadrivium must have a unique and universal formal cause. What this universal formal cause is or should be is not clear from the objection. Its main point is that in virtue of a principle or proportionality between a material and formal cause, if there is a universal material cause, there should be a corresponding universal formal cause, but it doesn't say what is this formal cause. To this question, the author gives the following answer, which is the text number 4. We say that the subject or material cause of sciences is twofold. One is general, the other special. The unity of a science depends on that of the general subject, to which all the particular subjects reduce. Of this general subject, no accidental attributes are demonstrated per se, but only of the special subjects, as in geometry we prove attributes of lines, surfaces, figures, and bodies, which all reduce to continuous quantity. As we can see, the author introduces a distinction between the general and the special object of a science to state then that the unity of a science depends on that of its general object to which the specific objects reduce. To this is added then that while specific objects are those of which proper attributes are demonstrated, general objects can't be subjects of proper demonstrations. That's why, as the example shows, though geometry is one science in virtue of its general object, which is continuous quantity, if it is not of this continuous quantity, but of the particular or special objects which are reduced to it, lines, figures, surfaces, etc., that proper attributes are demonstrated in geometry. Though it is not said here, we might suppose that the same thing holds for the other arts, for arithmetic, astronomy, and music. Then a second question is raised. If the unity of a science, here geometry, depends on that of its general object, to which the particular objects are reduced, and since the objects of the liberal arts of the quadrivium somehow reduce to quantity in general, should we take the whole of the quadrivium, and that's the question, of which it is the object, as a general unified science? So the text number 5, but then it would seem that the 4 mathematical special disciplines are one science, as any particular subject of which we demonstrate attributes reduced reduced to, sorry, I forgot to translate this, reduced to one general subject, which is quantity. But if that was the case, this would imply that there may be demonstrations of the specific objects, continuous and discrete quantity, that reduce to quantity, like in geometry. However, the author just said that there is no proper demonstration of those objects, as they are already general objects to which particular objects, as lines and figures, do reduce. That's why the author completes its answer by stating that the only unity in the quadrivium is at the level of art, not of the whole, just as the discursive of logical disciplines. So we have the text number 6, and we say that all the 4 special mathematical disciplines have unity as arts, but don't fall under an appropriate science, just as the parts of logic constitute an art, but don't fall under an appropriate and unified science. The arts of the quadrivium doesn't fall under one appropriate science precisely because the general objects, when taken specifically with regard to quantity, can't be subject of proper demonstration. Neither can we demonstrate proper attributes of quantity in general, which is the reason why the author adds that in somehow, which is the reason why the author adds in somehow cryptic conclusion that just as quantity is the universal material cause of the whole of the quadrivium, so the universal formal cause must behave with regard to the specific formal cause as a kind of reducing item or a kind of item, sorry, that allows to reduce particular sciences and objects to one general objects or one general science. So we have the text number 7. We say that in the same way quantity is the universal subject of the whole of the quadrivium. Sorry, the same is true of formal cause, but nothing is proof of quantity in general. So the formal cause is not specific or distinctive or of any special art of mathematics. So what does this mean concretely? This means that since nothing is properly demonstrated of quantity in general, neither this universal material cause nor the universal formal cause, the common mathematics, can be specific to some mathematical special discipline. In other terms, this amounts to say that common mathematics is neither a theory of magnitudes nor of numbers, nor of proportions, Patch Aristotle, and it has nothing to do with mathematical activity. Then, if it can't be a mathematical theory, what should be this universal formal cause? So considering the 3 aforementioned models of common mathematics, we may observe 3 things. The first is that if the universal formal cause of mathematics, that is common mathematics, can't be a mathematical theory, so the mathematical model, just as Aristotle's solution, is ruled out by the author of the Excessus. But 2 options remain, the metamathematical and the nominal model. We observe indeed a sort of synoptic approach, reducing the objects of the quadrivial arts to general objects, but not in the same Platonic way against which Aristotle reacted. We also observe a kind of nominal approach, as on the side of classifications, mathematics is seen as a label for the 4 disciplines of the quadrivium. Because the quadrivium divides mathematics, the mathematics which is intermediate in the Aristotelian Boecian tripartite division. So if it is not a mathematical theory, nor exclusively an analogical or nominal point of view, what do they consider as the universal formal cause of mathematics? That's the question. And after an exploration of some descriptions and common sources, it seems that what is aimed at by that expression was nothing but abstraction again. So I come to the last part of this talk, and I would like to note that the above overview of the history of the notion of common mathematics, as found in David Rabouin's book, lack an important figure on the topic, which was no one but Proclus. Leaving all the details aside, we should know that in one of the main aspects of Proclus' treatment of common mathematics in the prologue of his commentary to Euclid's Elements is one of these main aspects of Proclus is his identification of common mathematics through a mode of knowledge which is dianoia. Without ignoring the mathematical activity, rather the contrary, Proclus claims that what any mathematical operation manifests is a dianoetical reasoning which is common to all mathematical specific disciplines and must, by the way, serve as a model for all the sciences. This implies that the reduction to all mathematical arts to one, the reduction of all the mathematical arts to one science is or may be epistemological, and that all the mathematical disciplines do form a whole, which is mathematics, because each one, despite the generic difference of their objects, are instances of the dianoetic reasoning. So, despite that this position and this option may seem attractive for interpretation of the position of the accessus, it can be associated with 13th century views on common mathematics because Proclus' commentary remained unknown to them, I mean to medieval people. However, the case of Proclus directs our attention to a rather neglected aspect of 13th century descriptions of mathematics in our discussion, that is, that mathematics is an abstract science. That mathematics treats of abstract objects, that is, things considered without matter and motion in thought, but not in existence, is one of the most common places of medieval philosophy. So, if abstract quantity is the universal material cause of mathematics, why couldn't we think of the mode of cognition of quantity as the universal formal cause of mathematics? That's my hypothesis. Such an approach is not incompatible with the descriptions of each discipline given in the accessus, where the formal cause of each discipline has to do with the mode of consideration or of operation of a discipline. And we arrive to the section description of arts, which is the description which is given by the accessus, a fourfold description of any science where we find the fourfold Aristotelian causal model. And what one has to keep in mind is the description of the causa formalis of all these sciences, which is all it has to do with the mode of consideration or operation of these arts. So the same way, just as speculation on the nature of number in the case of arithmetic, demonstrations and construction of figures and so on as formal causes of the discipline of the quadrivium are the way in which the species of quantity are known at their level. So in a similar way, I think one could think of abstract mode of cognition as the way in which the whole of mathematics knows quantity, that is, as the formal universal cause of mathematics. After all, it is in virtue of the abstract character of the objects of arithmetic, geometry, and especially of music and astronomy, despite their physical side, this is a question for another discussion, that the latter, I mean the sense which are also called scientia mediae, are closer to mathematics than to physics. Accordingly, it would then be abstraction that grants for the reduction of the species of quantity to quantity as a genus, abstract quantity, and for that of the liberal arts of the quadrivium to a common speculative science, which is mathematics. So any science which abstracts from matter and motion in thought, not in reality, is mathematical, or what is better, falls under a mode of knowledge which is better instantiated by abstraction. The limitation of such a mode of cognition to quantity, despite its instance in other domain, has to do with what I call in my dissertation, but which for the sake of time I can't develop here, what I call the medieval problem of demarcation of mathematics, which is basically a discussion on the question of why, if we can also abstract other notions in other domain than mathematics, why one should say that mathematics is the only science which can abstract, and why it treats only of quantity, if other qualities may also be abstracted. So, to conclude, I would ask anew if that was the 13th century philosophers aimed at, but the universal formal cause of mathematics. I mean, if the universal formal cause of mathematics was abstraction, a mode of knowledge, and so on, what were these sources? I mean, why they came to this conclusion? To answer quickly to these questions for the sake of time, it seems to me that they owe such a view to the Porretan and part of Chartrian traditions of Boeotian commentaries. In those commentaries, it was common to find reference to mathematics, the speculative science of the Aristotelian Boeotian tripartite division, as synonymous of abstraction simpliciter, without direct association with number theory or Euclidean geometry. For instance, for Gilbert of Poitiers, whose commentaries were well known, mathematics has more to do with abstract thinking than with arithmetical or geometrical operation. In this sense, it was synonymous of abstract or conceptual thinking, which gave natural philosophy and theology their concepts, which concepts were what they designated as abstract terms. So given the relevance of Boëtius' treatises, especially the Trinitate, and seemingly that of the commentaries of Gilbert of Poitiers and the other people, given this relevance for 13th century philosophy of mathematics, it's not impossible that it be such a view that we see in the didascalic texts, as well as in other treatises and commentaries, Thomas Aquinas included, along with mathematical treatises, as to make room for a conception of the whole of mathematical arts as instances of a unique mode of knowledge, abstraction, which gives any mathematical object, lines, figures, numbers, etc., its mathematical formal reason. I mean, what mathematics in this case, and this is my hypothesis, what mathematics stands for in this discussion is for the whole of mathematics, and as a part of meta-mathematical description, which is not like those of the ancient Platonists, but which is nourished and inherited from the commentaries and the commentaries and the views of the school of Poitiers and the school of Chartres in France and in Paris in the universities of 13th century. So thank you very much for your attention.
Thank you so much, Daniel. Yeah, I put the order of the talks more or less was just about time zones, moving from east to west. But I'm really gratified that these first talks are so much in dialogue. So thank you to Daniel, and of course we are open for questions. Yes, Eduardo, please.
Just a suggestion more than a question. I strongly recommend you look closely at Aristotle's Metaphysics, Book 5, Chapter 28, where he makes a distinction of how genus is said. He gives 4 modes, but 2 are relevant to this question. And these are the subject genus, which is how the sciences are united, and the sciences are distinguished by their principles, meaning the principles of the subject genus. And then there's what is later will be called the predicable genus, which is the categories, basically. And if you look at these 2 distinctions, one is really what the scientist does. You can look at that in the posterior analytics. That's the subject genus. And the predicable genus is used by the also by the metaphysician and all the scientists, but primarily it is a logical question. And the other thing is the distinction between the subject and the object. They are definitely not the same, though they are analogical. And you can see this in St. Thomas in the Summa Theologia. He gives what kind of analogy there is. So the potentia, the potency or the power, or the habitus, is to the object what the subject of the science is to the science. And that's all I wanted to say. Thank you. Fantastic, by the way, really.
Thank you for your suggestion. I'll be looking up. Thank you very much.
All right, Andrew?
Thank you for this talk and for the sort of window into the wider world going on around Thomas Aquinas that I didn't really know anything about. I want to ask, I'm having a little trouble understanding these texts. How come he says that the mathematical disciplines have unity as arts in text number 6?
Sorry, may you repeat the question, please?
Yeah, sorry. In text number 6, the author of the Accessus says that the mathematical disciplines have unity as arts. Why does he say that?
Okay. I mean, I think this is the passage. I think it is very or somehow cryptic. I mean, the Latin is not too clear. but the way I interpret it, and with one of my supervisors, is this one. I mean, what he tries to do is to indicate that if the unity is thought from the point of view of the mathematical activity, the unity cannot there can't be unity for the whole of mathematics, because nothing is demonstrated in mathematical activity of quantity in general. And I think this is what he's trying to say. I mean, from the very point of view of mathematical activity, there is no unity, but he's rather suggesting that from another point of view, I mean, a point of view which would be formal or epistemical, I mean, which allows to describe the whole of mathematics as abstract sciences. There can be such a unity, but not from the mathematical point of view. I mean, and that's why the key of this argument is that nothing is demonstrated of quantity in general, because, and this is another aspect of other treatises or didascalic text, and I think to the pseudo-gross test Communia Logice, which the discussion about quantity states that the quantity which is treated by the mathematician has no real, no theoretical unity, but only formal unity as abstract object. I mean, as being abstracted from matter and motion, etc. But it is what the pseudo-gross test says, and I think these texts are kindly close to one to each other. Did I answer your question?
Yes. Yeah. So you see that as something that is saying the same thing as your main thesis here. I see. Thank you.
All right. Anyone else? All right. Well, I guess we'll just loop back around then, Eduardo and then Andrew.
I'm sorry, to go for seconds, but this reminded me of something about Proclus. And last time I said Porphyry, but it's really Proclus, the commentary on book 1 of Euclid's Elements. And there are very interesting places where he goes right to Aristotle, like when he talks about demonstrating proportionality for arithmetic and for geometry, and he says that let the geometer use the principles of geometry and the arithmetician the principle, and you can't have a demonstration. So this is precisely this distinction. So if you use the genus of the logician, so to speak, the predicable genus, then your quantity is united in ratio. But if you use the subject genus, which is the genus of the scientist, then they are not. That's all. Sorry.
Yeah. I agree.
And Andrew.
Sorry to double dip as well. In the research for my paper, I ran into something else that seems to give a unity to mathematics, and I wanted to ask what you think of this. Vincent Smith, in the lecture on the subject of geometry, asserts that mathematics is about a composite. It's not about just quantity on its own, even though there's an abstraction. And of course, it's a composite with substance as the matter, because for Thomas Aquinas, substance is what intelligible matter is. And Vincent Smith digs up a text in the commentary on the Metaphysics where Thomas Aquinas says that the subject of mathematics is ens quantum. And I don't know what to think. Could that be a possible unification of mathematics because it's unified by all being about substance in a certain way, or ens quantum?
So I had a lot of things to say about that, but I will limit to two of them. The way I understand the notion of intelligible matter in Thomas Aquinas, which is designated as substance, it's a kind of functional term which aims to ensure that we don't separate completely quantity from this object. I mean, I have no time to develop that here, but in the commentary on De Trinitate by Gilbert de Poitiers, Gilbert insists enough on the fact that the mathematical consideration is in the Latin formula is to consider something sine, to talk of something sine materia, but not to think of something as being sine materia. And the way intelligible matter described as substance is used by Aquinas is, in my opinion, a way to grant for the non-separation of quantity from their subject, which is the key of his opposition to Platonic view, marked by separation. But there is another sense of another context where intelligible matter is considered, and which it designates the continuum, in which I don't know what is the link with this with Albert the Great theory of the construction of lines by the imagination of a point in the continuum, which the imagination of the motion of a point in a continuum as to form the line. But I don't know. It's too. I have no time to develop. Sorry about it. I think this notion of intelligible matter is. No, sorry. I prefer to stay here because I have no time to. It's too long. We could email. It would be better if.
Sounds good. Yeah, sorry for that. That was a bit of an oversized question.
Oh.
Thank you.
All right. Well, let's all give our thanks to Daniel.
May I have a question? One more.